Part 2 wants us to show that 2 to the power of 4/3, 2 to the power of 5/3 lies on the curve. So we just need to show that if we substitute those 2 points in, those 2 coordinates in for x and for y, that the left-hand side will equal the right-hand side. So that's the first job. So 2 to the power of 4/3 cubed will just be 2 to the power of 4. That third cancels with that 3. Plus 2 to the power of 5/3 cubed, again that's just going to be 2 to the power of 5, equals 6 times 2 to the power of 4/3 times 2 to the power of 5/3. Just be careful with show that questions. Don't just grab your calculator now and get the final answer. I'm going to do a bit more working out to show that the answer is definitely equal both left and right. Over here I can use my index laws. If we've got the same base here with these 2's and they're being times, we're going to add these powers up. So that's going to be 2 to the power of 9/3, which is cubed. So 2 to the power of 4 is 16. So we've got 16 plus 32 here. And here we've got 6 times 8. And that's obviously 48 on both sides. So that's correct. So that's the first little bit done. And it also says to show that when at these 2 points, at this coordinate, dy by dx equals 0. So we need to substitute it into here and show that it equals 0. I only need to put it into the top. So that's 3 lots of 2 to the power of 4/3 squared. Take away 6 lots of 2 to the power of 5/3, just 5/3. I probably should put it into the bottom as well, and then just show that the top bit's 0. So that's 6 times 2 to the power of 4/3. Take away 3 lots of 2 to the power of 5/3 squared. So I am now just going to type all of this in on my calculator because nothing's going to cancel nicely. So 3 bracket 2 to the power of 4/3 all squared. Take away 6 lots of 2 to the power of 5/3 is hopefully 0. Which it is. So I don't need to work out the bottom bit. I know the top bit's 0, so it doesn't matter what's on the bottom.